Welcome, everybody. I'm Charlie, the moderator of this session, in my position as chair of the European Nuclear Society Young Generation Network, and also working as a researcher in Jülich Forschung Center in Germany. So yeah, the topic of today that you all know, the restart of the potential restart, the technical feasibility of the restart of the German nuclear power plants. It's a topic that also affects me in my daily life, in the price that I pay for electricity every month at my home. So yeah, and I'm really happy to see so many of you here. I'm really happy to see the numbers of the people attending the meeting today. So welcome, everybody. I will stand a bit this welcoming introduction because the numbers of people joining is still going up quite fast. So maybe for some organization matters of today, I can already start explaining that we will have approximately a 40 minutes talk from Martin that I will briefly introduce now. And yeah, let's see. And but we really want to have enough time for the Q&A for sure. After discussing the technical challenges, I am sure that you will have a lot of technical and non-technical questions that Martin will be happy to address. And yeah, for the questions, we do not have a Q&A section today in our meeting. We only have the chat. So my main task today will be follow up what you say in the chat. You can ask. We can do most of the questions at the end of Martin's talk. But of course, if you have any critical thing that you want to comment or you want to know during Martin's presentation, I will be taking a look to the chat. I can stop Martin because you cannot unlock your mic or your camera. But I will be taking a look to the chat to introduce any critical question that you may have while the presentation is ongoing. And if not, all the other type of questions, we will leave it to the end. All this said, Martin, I'm giving you the floor. Martin will actually introduce himself. What I can say so far is that he's the managing director of Westinghouse, Germany, and he's also today here with a second hat, so as the spokesperson of KernD, the industry association of Germany. So yeah, Martin, please, the floor is yours. I will be here in the background taking care of the logistics.
All right. Thank you very much. So let me share my screen, so you've all seen me, maybe in a bigger picture. Now I'll switch to the slides. Hopefully it's working, looking good. Okay. So yeah, welcome. Well, first of all, thank you very much for having me as a presenter at ENS. That's pretty exciting for me because I do a lot of, as a spokesperson of KernD, I do a lot of chats, webinars, even podcasts that are usually strictly addressed to the German public or German technical people. Going European with that topic is quite exciting. So what is it that I want to share with you, and what should be what you're taking away from this presentation? I will actually, although the title seems to be pretty technical, and I was also introduced as somebody talking about the technical things. Of course, I have to, and I want to, because we would be, if we would restart plants in Germany, Westinghouse and myself would be doing this. So of course we have to take a look at the technical matters. But at the same time, Germany is in a very unique situation. I mean, it's technical issues is probably the least problem that we have. It's public perception, it's political situation, it is the legal situation, it's a situation of utilities having changed their plans, needing security. It's what the authorities are doing, what they're driving for. So this is, the restart in Germany is an extremely complex animal, and I try to shed some light on what would need to happen including technical, let's say, advances and well, repair and replacement in the plants in order to come back to nuclear as a country, which I personally think we'll do anyway at some point, but we can do it quickly or we can do it slowly. And I cannot recommend slowly because it means that you have to rebuild a lot of things, not only the plants, but also a infrastructure that's actually quite difficult to do, and it takes time and it takes money to develop that. So that's going to be the essence. So I gave you the essence even before I started really with my presentation. But anyway, so let me quickly talk about myself. Yeah, I'm working for Westinghouse since 22 years roundabout. I'm a mechanical engineer by education. I did a PhD or doctor thesis in product development. So it was not nuclear. I was actually working with a lot when I did my PhD with automotive companies. I did this in Munich, so it was BMW quite a lot. And I think I learned a lot about product development and technology evolution. And I tried to also talk about that in my speech a little bit. But when I joined Westinghouse, I turned nuclear. And I've gone through a lot of, probably kind of a classic career. Started off technical, but then drifted into all kinds of different management positions, which were very interesting. I always learned things. I understood more about the industry, but also about how Westinghouse and a big company like that is ticking. And I finally, now it's in 3 years, I'm the managing director of Westinghouse Germany. At the same time, I joined the board of KernD, which is the Association of Nuclear Companies in Germany. And just 2 months ago, I was announced as the spokesperson of the board of KernD because I volunteered. So now I'm picking up pace with having webinars and speeches like that. As I said, a lot in the German bubble. So I'm really happy to go beyond the German bubble and maybe speak to the European bubble. There we go. Okay, so that much about myself. Let's go on. Okay, here we go. Why am I in Germany, nuclear country, very, very powerful plants, well developed? I would say probably top of Gen 3 plants with our convoy plants. Why are we talking restart? And the reason is because we have this thing called Energiewende in Germany. And that's the reason for all of that. Energiewende is a German term. And I think it turned into an international word by now, probably. And it picked up pace more or less after Fukushima. But it's been defined long ago by Öko-Institute, which is a ecological research facility, and they prognosed that it's possible to abandon nuclear and combustion, or let's say gas, coal, fossil, and still have an energy economy that serves an industrial country like Germany. So they said in the 1980s. Since then, it's out there. May make sense, may have made sense maybe at that time, but a lot of things happened since then. Certainly a big push was Fukushima, when Germany finally really decided to phase out of nuclear. With a clear set plan, and also with let's say a legal framework that doesn't even allow us to get out of that anymore. So, and the plan was, and I think that's been in the head of everybody, is that we could be kind of a maybe a role model for at least for the rest of Europe, to show, yes, this Energiewende is possible. You can abandon nuclear, you can abandon fossil, and you can be a well-developed industrial country. Which means if you're a well-developed industrial country, you need to have, in my opinion, need to have stable electricity, and you need to have cheap electricity, because that's, electricity is one part of industry. Needs I would say needs three things. They need to have raw material, they need to have energy, and they need to have technical components or people that develop technical components, and then you can fabricate products that are worth more when you sell them than like the initial ingredients. And as I said, electricity or energy is one ingredient, so it should be cheap in order for you to be competitive. So where did we end up? What I put up here is it's a portfolio diagram where the European countries that produce per year more than 50 terawatt hours, where they stand with regard to electricity price and CO2 emission per kilowatt hour. And I hope you're kind of familiar with portfolio diagrams. So there is, you see here, this is the price. The higher you are, the higher you bubble, the higher the price. And you see to the right, the further right you are, the more dirty you are, to put it this way. And this is no offense against Poland or the Czech Republic. They're working on that, but there are two outliers. But let's focus on this area, because that's a pretty dense area where there's a lot of countries having a position. So if I just kind of stretch this out, you see that Germany is in the upper right corner. And when you know portfolio diagrams, that's where you don't want to be, at least with these scales, because that means you're paying a lot and you're still emitting a lot of CO2. I mean, as I said, there's two outliers, which is Poland and Czech Republic, but they're working on going back left, and they're actually still. I mean, they have reasonably good prices at least. But Germany is in the upper right corner. It's not where you want to be, and that's after we put a lot of effort into driving our Energiewende forward. So we've not achieved the goal, and that's a problem with these political initiatives if they're not clearly defined. And we're all, I mean, a lot of us are engineers or have a scientific background, and we all know, I mean, if you want to achieve something, you have to define what's my goal. And you define this goal not by, I want it different than it is now. You define it, where do I want to go to? And you define this with values, with criteria. Criteria should have been, we want to be low in CO2, and we want to be low in price. I mean, every German would agree that this was the initial plan. But what we did not measure that against these two criteria. So we ended up in just the perfect opposite, and that shouldn't be. And if you look, I mean, if you take actually, I put a circle. Let me see. Here's so they're the two outliers, but I circled the countries that have nuclear in red, and you see they're all, with the exception of Netherlands, but at least they have a low price, they're all on the left side of the screen, and some of them are even in the left lower quadrant, which is exactly where you want to be. And so that is where Germany wants to be. And my theory, because I'm a nuclear guy, is we'll only get out of this upper right corner if we turn nuclear again. And there's a slow way and there's a quick way. And the quick way would be to restart the nuclear power plants in Germany. And can that be done? I mean, are we already across beyond the point of no return, or is it still possible? Well, spoiler, it's still possible. But of course, I mean, it's going to be an invest. But let's first of all take a look at, and that's probably for some of you that's common knowledge or there's no-brainer. But I still want to emphasize that because sometimes it's not clear. If you take a company as Westinghouse, we basically do everything. We build plants, we help operating the plants, and we dismantle them in the end. And so the new build is actually, I mean, we're not making a margin by building plants. We're making a margin, to be honest, and that's the same for a lot of industries with these capex, capital expenditure type of project. We do our margin when the plant's operating, because that's when our customers are actually earning their margin. and we help them to earn margin. That's the operational model, and that's the business model of Westinghouse and all the other companies. I mean, Framatome is the same. I mean, the Koreans are the same. So it's all about electricity. It's not about new build, because of course you have to build before you operate, and it's not about dismantling, but of course you have to dismantle after a plant did its operation and did its job and produced as much electricity as possible, and then you can shut it down, and then somebody needs to dismantle it. And it's part of the value proposition if you see it as a whole. But seeing it as a whole means you have to, in between new build and dismantling, you have the maximum period of electricity production. You have to do that safely. I mean, with regard to nuclear, but also with regard to people, I mean, personnel. It's got to be also always be part of. I mean, it's got to meet state of the art or state of technology and research, which is good because that makes us improve the plans as we go along. But in the end, what needs to come out is you have to have maximum output at the best availability and the lowest operational cost. And that's all our products, all our services that we do during operation to the plants are measured by these three criteria. And I put some, you'll see that, I mean, when I did the operation arrow is actually several stages, and that is because all the plants initially, also the German plants, were set to a lifetime of 40 years. That was not because we thought that after 40 years they'll just crumble and disappear, but because at that time I think people thought that after 40 years probably there's going to be the next level of new reactors already being built and being operated. That did not happen. Is that because there is no development? No, it is because it turned out that these plants are so robust, they can do much more than 40 years. So I think globally we'll probably see most of the plants in the Western world go 80 years, 80, and we're already thinking about 100. And that is because the plants can take it. They're not. At some point, they should be taken over by the next generation, even the next generation. But they're just really good plants, and they're safe, and they do exactly what I put up here. So far, they do an output at a high availability and low cost, so they're absolutely competitive with regard when you compare them to other forms of technology to actually to produce electricity. Yeah, so 100 years. I'm pretty sure we'll see that if we live long enough. So the younger guys, probably myself, might even be. Well, we'll see. So that is how the industry is ticking. So it's all about production of electricity for a long time, as long as possible. So, but that means, as I said, we're always going. I mean, we're trying to achieve, is if possible, based on the initial technical concept of a plant. We're trying to keep it at the state of the art, of state of technology and research. And why is that? Because we're trying to lower as we go along from day 1 to year 100. We try to decrease the core melting frequency as we go along, because the longer these plants are running, at some point, I mean, statistics or probability might kick in, but you can beat that. I mean, you can beat that by actually lowering the probability for any damage or any catastrophic event. And that's what you do, and that's why these plants are modernized all the time as we go along. I picked up here, I'll talk about some of this modernization now, and that's going to be the key of the technical part of this presentation is what do we do with those plants in order to extend the lifetime? And so I picked a PWR here, very simple, and as you can see from the values, it's not really high temperature. So that's temperature is not so much the challenge or the issue technically, but we have high pressures. So that when you look at the steel components in there, they're pretty huge. They're heavy. They have I mean, tremendous wall thickness. That is because of the pressure, because we're talking high pressures, like 160 bars for the primary circuit. And the other challenge is that that these I mean, compared to other like coal plants, gas plants, these units are very powerful. Actually, this is a primary and secondary part. As I said, primary, high pressure, which means high wall thickness. But also, if you look at the electrical output, 1.4 gigawatt is that's big. So which means you have to have a lot of water, you have to have a lot of steam, you have simply big components. You have big components by volume, and they have a big wall thickness, and that's what characterizes the steel components in a power plant. Yeah. And one thing why, actually, just a side note, why, in my opinion, nuclear power plants have a certain advantage over other classic plants that can deliver a base load is, I mean, you can load them and they run for 3 years. You don't need a pipeline. You don't need a train bringing coal all the time, constantly. I mean, you can just run them. Of course, you need to. I mean, you have to change the fuel elements every once in a while, at least reshuffle them. But basically, one core loading lasts for 3 years or more. And you can and these cores are very dense, so you can probably store another core on site that you can already have delivered, and then you can go 6 years without anything when it comes to fuel from the outside. And that's a big advantage in times when like global politics are sort of unstable. So let's take a look at the big steel. Oh, no, sorry. First, I have a different order of slides. First of all, I talked about lifetime extension. Why do I talk about lifetime extension when we're talking about shutdown plants? Because if you restart a plant, you need to do that for a certain period of time. And we'll later look at the age of the German plants. The German plants were just approaching 40 years, so they would have been up for lifetime extension. And what we do for lifetime extension, Westinghouse, but other companies have a similar approach. We're looking at all the components and all the systems. We consider them assets that need to be managed. And so we work with our customers and we say, okay, we take a look at your whole plant. We'll look at it component by component, system by system, and we'll check, first of all, how did you run the system, the components? Was it subject to accelerated aging or not? And aging in terms of steel means it doesn't just age by time, it ages by the way it experiences loads while being operated. So, I mean, changes in the load, temperature gradients, that means aging. Running at full load as stable as possible means minimum aging, which means extends your lifetime right away of the component. But that's what we do. We look at all the components. We consider what's the status. Have they been replaced maybe recently because there was a damage or anything? Are they could they be replaced? And also, if they would replaced, can we even increase the performance? And that's what we did a lot. What's being done actually a lot with BWRs, so the other design, boiling water reactors. There's power up rates, so that can be done. And it usually, if you want to achieve a certain power up rate, you need to replace some of the components, and that's what's being done all the time. And these components come out of the plant. They need to be dismantled. And by the way, that's how Westinghouse learned how to do dismantling. We didn't learn this by with shutdown plants. We basically developed all these technologies by power uprating BWRs, especially in the north, and then taking care of the replaced components. The old components, when they came out, they need to be dismantled, segmented, packed, and that's where we got our knowledge from, which is an interesting. It's like a fun fact. Yeah. So, but yeah, you can replace components, and you can do this, and at the same time do a performance improvement. Very interesting when you think about 60, 80, 100 years increasing the output for decades. That's powerful. And so that's how we approach plants that are up for lifetime extension. And that's the same approach that we would use with shutdown plants. The only difference is that the plant, instead of finding a component that would be worth replacing because it aged too much for, I don't know, maybe for 80 years, or there's value in improving the performance in the shutdown plants, because we already started to dismantle, some of these components are simply gone. So of course we have to replace them because they're not there anymore. But we do it with the same logic. Okay, so when you look at big steel, and I'll focus a lot on steel. That's because I'm a mechanical engineer. I'm not an electrical guy, so I'm not talking about electrical and INC. I'm looking at steel. Well, but I think steel is usually big steel has a long lead time in production, so it can and it probably would be on the critical path for restarting a plant if you have to repair or even replace a component. But here you see the big steel. I mean, steam generator, vessel head, the vessel itself, the internals, the piping, and the pumps, basically. I'll talk about that a little bit. And as I said, in a German plant, some of them just simply disappeared or samples were taken, so they have like a little hole in them, or they've partially been segmented. So what you need to do is, for some of those components, if they were not touched yet, you still need to verify is it still safe to operate them, or you can repair it, or you can replace it. And I'll look at the replacement first. And to be honest, I talk a lot to just normal people, non-nuclear bubble type of people in Germany, and they think there are still a lot of people who think that once you start to cut any steel in the plant, it's basically damaged and it's point of no return. Absolutely not the case. And why I was talking about lifetime extension before is for those components, some of them have already been segmented in German plants. These are components that have been replaced in other plants all around the world in order to extend the lifetime or to improve the performance. So there is references, there's experiences for that. Reactor vessel head, just take that and here's a few pictures so you can better see how they look in reality, because I talked about it. They're big because they're big steel. I mean, vessel head has been replaced quite often. I'm sometimes in Betznau in Switzerland, and from some of the meeting rooms, you can actually see the containment, the concrete containment, and you see a piece that's actually lighter than the rest, and that's because we cut a hole in there in order to put the vessel head in there, the new vessel head in there when we did the replacement. So it has been done. It has been done for old plants. Even if you cannot get it through the hatch, you just cut open the containment, you bring it in, you bring the old one out, and you close the containment again. It can be done. It has been done. Steam generators, quite a lot. There were issues in early designs with the steam generators. So they have been replaced quite a lot. And we currently even do this also for French plants in EDF. And just as an example, there was even a French plant when during the replacement of a steam generator, they dropped the steam generator and it fell down and damaged a lot of concrete and other components in containment. And even all this other damage, I think it was Paluel, could be repaired, and the plant is operating operating again. So that was almost like a unwilling segmentation activity in containment, and it could be recovered. So there's a lot is possible if you want, and it's worth it. Core internals, we currently do this even in a Finnish plant that we're replacing some of the core internals because they were they showed wear and aging, so we replaced them so the plant can continue. Reactor coolant pump, even easier. There's a German company called KSB. I mean, I talked to them. They said had all the time. I mean, for the operating plants, operating with KSB plants, they were ready to deliver a replacement pump anytime when needed. So that was even, I mean, was simple, relatively simple. Yeah. And I want to go back to the steam generator example once again. First of all, I mean, this damage for me was impressive that the plant could be restarted, but also what you don't see here as a replacement component is the reactor vessel. I didn't put it in red because that has not been done before. All of the other components has been done partly, actually many times. Reactor vessel was not done yet. And so in the past, reactor vessel, if for whatever reason would need to be replaced, that was considered the point of no return. That was considered the one aging effect or damage that cannot be restored. But when there were issues with some of the vessels, I think it was in Switzerland also and in Belgium, it's been years ago. We put together a little team of experts, asking them, hey, if is it really true that reactor vessels cannot be replaced? Can you take a look at that with all your expertise and determine if it's really impossible, and find out what is it that makes it impossible? And they sat together, and it's interesting. They said it can be done. It has not been done yet. I mean, it would take a lot of lead time. You would need to develop new strategies to bring it in and bring it out. But what these guys basically said, if we can replace the steam generator, which is a huge component, and also that huge component needs to be put into the primary circuit, so it has to be placed exactly at the right position. It needs to be welded into the primary circuit, and I mean, you create a weld, but basically the integrity of the primary circuit needs to be as it was before. I said, if we can do that with steam generators, why not do it with a reactor vessel? So we think it's not the ultimate point of no return if a vessel needs to be replaced, but that's when, from a economical perspective, it becomes really difficult to do the math and justify having a repair like that. And repairs like that also always introduce a risk. As I said, reactor vessel not been done yet, that means risk, and need to take this into consideration. I mean, commercial risk and schedule risk. Yeah.
Martin, there is a question on the chat that I think that could be addressed now. So people is asking about specific examples in the German fleet where these components have been damaged. So I guess that it's pretty.
I have a slide. I have a slide in the end where I can talk about that a little bit, but maybe as a little note in between. It's a little bit difficult for me to talk about that because unfortunately it's quite ironic, but Westinghouse Germany is doing some of the dismantling of these components. So we have the contracts for doing this. In some cases we actually do it, or we prepare for doing it, or we have done it. So we know about the status of the plants. But having a contract like that comes along with some confidentiality agreements, which means I'm not allowed to talk about it, at least not specifically. But I have a slide later, and there you'll see when the German plants even started to do dismantling, because that's when they got approval by the authority to do it. And you'll see that it didn't start right after the shutdown. It took quite a while, in some cases pretty long, in order to get the approval to do the dismantling. And before that, plants, at least in theory, had to be kept in a operational status. And so that tells you that some of the plants are actually absolutely not far down the road. So they're far away from the reactor vessel. They still have the internals in there. Steam generators are still in there. Vessel head may be gone. Coolant pump may be gone. Some of the steam lines or feed water lines may be gone. But that actually takes me to the next slide. And again, I'll talk about this later a little bit. but let me continue, because what can be repaired? Because what I just talked about was, for example, piping. If piping has been cut, I mean, there's you have to repair, or you have to at least put pieces in there and connect it somehow to the nozzles of the vessel, of the steam generator, all of that. And so what you do there is actually also quite simple, although it's a piece of art. I mean, the key is welding. Welding is a technology that has been taken pretty far in nuclear. And so what welding does is, and again, I probably don't need to tell you guys that, because you have expertise, but welding is basically, you are creating new base material, and you're connecting it to existing base material that, in theory, there is no, I mean, there's no difference between old and new material, and it's perfectly connected with one another. It's not like gluing things together. I mean, you create base material that connects and expands with regard to the existing material. And so what you see here is that's actually a mock-up where we qualified remote welding. It's not automatic welding, but it's remote controlled welding. And so we're replacing a lot of, let's say, missing material here. And what we do here is we do weld by weld. And the biggest problem you have when welding in situ, which means in the plant, in the position welding, there is, you cannot do heat treatment afterwards, not as you could do it in a factory where you manufacture a component. But there's tricks that you can play, and in that case, I'm not an expert for that. So if you have detailed questions, I can direct you to somebody who knows it very well in Westinghouse. But what you do is you weld in a way that, I mean, you put one layer of welding up there, and then you wait for exactly the right time until this layer cools down to a certain temperature, and then you put the next weld on top of that. So the next weld on top of that actually introduces heat into the existing layer, and that's almost like a heat treatment. And you do this layer by layer, layer by layer. So every next layer does heat treatment to the previous layer, and then you go, let's say, do n+1 layers. So you have heat treatment all the way through, and then you remove just the last layer because it's not being heat treated. And that's what you see here in the lower right corner. I mean, it's from the outside. I mean, you can even see that this is actually base material. Of course, it's not perfectly identical as it would be like true base material coming out of the factory. But then you have ways to deal with that. I mean, especially, I mean, you can do you do periodic testing on all the welds, and then if you find that there was an irregularity in there, and it might be a crack that could be growing, you can repair again, for example, or you can do all kinds of other treatments in order to prevent crack growth. And that's another big advantage in those plants is you're dealing with ductile material, so cracks will grow over time, so you can find them and you can monitor them and you can decide cycle by cycle what to do with it. And in the end, you can always repair. Like that, you can repair your repair again. So that's how you do repair. So welding is really, that's the piece of art that allows you to restore a steam line, that allows you to introduce steam generators into, replace them, put them into a primary circuit. And again, it's not something that we come up with in order to give it a first try in the German plants. It's been done. And for me, steam generator is the perfect example of what can be done, because these steam generators are very complex to manufacture. They are very heavy and big. They're difficult to bring into containment. they need to be placed in the primary circuit and also the secondary circuit, and it's working. We have multiple experiences for that and examples and references. Okay, let me continue. So here's some conclusions, but there's going to be another slide after that. So many nuclear power plants in Germany have been partially dismantled, but they can be restarted. And there's companies who can do that. And these are companies that have experience with that. And they have experience because of lifetime extension and power upgrades all across the world. So with that regard, a restart in Germany would, from a technical perspective, would not be so unique, but it is very unique from a political perspective, from a legal perspective, from a public opinion perspective. Very difficult, and we experienced that. But I mean, as I showed you actually in the first slide with the portfolio diagram, we're not going where we want to, and I think by now we can say that the path that we took probably doesn't take us there. So we need to re-steer, and re-steering and looking at the other countries, seeing what they do, is actually going nuclear. So Westinghouse and Framatome and others, we're ready to KSB, we're ready to support. We would love to do this in Germany. Because it makes sense. It makes perfect sense from an engineering perspective and also from an economic perspective. And what's also important, and here's the chart or the table that I was talking about before. If you look at I put not all the German plants, but some of the German plants, the ones that were shut down, I mean, latest, not all of them, but some of them, you see they're actually quite young. They're all below 40 in true years of operation. So, I mean, if you think about 60, 80 years, I mean, they would be up for it. And if you take the convoy plants, which were the latest design in Germany, they've been running extremely stable. And also we used them in the past a lot for baseload, because we're not like France. Well, actually, there's so much nuclear, which is good. There's so much nuclear that actually have to follow the demand curve. We did that with the other plants, and the German nuclear power plants were pretty much steadily baseload as much as possible, 100%, which means there was not much aging. So, I mean, they're below 40, but when it comes to operation and temperature gradients, they're even younger than some of the other plants with that age. So they would be up for lifetime extension. And that's the other thing I want to talk about is the column on permission given for dismantling. For all these plants, for most of these plants, they were in 23 and even 24. I mean, some of them even late 24. So there's not much that can be done in a year. Which means you can, I mean, as I told you before, I cannot perfectly talk about the exact status of each plant, but you can be sure that there's some of these plants are far away from having their reactor vessel dismantled or segmented, far away from that. There may have been samples taken, but that can be repaired. Not easy for a pressure vessel, but something I know. I even personally know some guys here in Westinghouse next door that would love to do that, because it's a super exciting challenge, and they think they can do it. So these plants are young, and they can go at least for another 40 years, at least some of them, and they're not far down the road in dismantling. So I think they should be considered. But that takes us to a political problem, and I didn't put that on a slide, but I'll try to describe that. I think there's three types of countries. There's the countries who turned nuclear and they remain nuclear. They're on one side of a hill in a valley, and they feel fine there. Then there's a hill, and on top of the hill is all the countries that have not really decided yet. They're not nuclear yet, but they've not phased out of nuclear. some of them are actually willing to turn nuclear. So they're on top of the mountain, and they can go both directions. They can go towards a nuclear country or towards a non-nuclear country. And then there's the other side of the hill, and that's where Germany is, for example, because we were nuclear and we consciously decided to go from one side of the hill to the other side of the hill. And I can tell you, once you've done that move, it's very difficult to go back to the other side, because don't think that you're on top of the hill and you can still decide. These, from a political perspective, from a legal perspective, public opinion perspective, you have given strong arguments, or at least you thought there were strong arguments to move to that side of the hill. And it's very difficult to go back to the other side, because there's going to be resistance. You got to be bold. You got to risk something politically. It's a project that takes you beyond the next legislative period, which is difficult, especially when it's politically unstable, and it's currently quite unstable in Germany. I mean, we're still reasonably stable, but we had one government that collapsed before the end of the period. That's pretty unique in Germany. That woke up a lot of people in Germany, because that usually didn't happen. So we're on the other side of the hill, and we will need to go uphill and then downhill. So we have a long way, but there's a tunnel through that hill, and that is to restart the existing plants. That would be a quick way to keep everything alive. But as I said, it's difficult, and we can talk about that also in the question and answers, what need to change in order to do that. I have one more slide, and that's probably something I don't need to convince you guys probably to be nuclear and to be nuclear fans. But if you're not yet, I mean, I hear in Germany, I hear a lot that nuclear is just a bridge technology, and it takes us to the real future technology, which is renewables. I can understand that, I don't know, from a ideological perspective, but I cannot understand it from an engineering perspective or from a physical perspective, because there's so much potential in nuclear, and the facts are out there. I mean, you cannot retain the scientific facts. I mean, when Einstein came up with the equivalence between mass and energy, that was it. It was out there. You can't get it back into the, I mean, you cannot neglect that. You need to, in order to prevent nuclear from further developing, I think you need to travel back in time and probably kill Einstein so he doesn't come up with that formula. But when it was out, that was a done deal. It's working. You can get, you can transform mass into energy, and the factor in between is huge, and it's doable. It can be done, and it will be done. Yeah, and there's a few other scientific achievements that brought us there, and that's been done in the past. It's not. I mean, this is, from that perspective, it's already an old technology, but it's still developing. And why I say that is, there's a concept I came across that when I did my PhD for technology development and product development. When you change from one technology to the next, like when you really want to do a step change, a quantum leap type of change, to go from one basic technology to the next, you need to go down a little bit in performance usually. And you can take the example of, I mean, propeller planes and jet planes. Propeller planes at some point were quite highly developed. Jet planes were coming up. They were crappy. I mean, they were crashing. They couldn't get far. They were hard to maneuver. But it was clear that this technology, jet-driven planes, would take over at some point. They just need to go through this S-curve. You have to invest into development. For a while, not much advancement, but then really it picks up pace, and that's when you get into this increasing piece. And at some point, you'll reach the end, or more or less, I mean, the saturation of technology, and that's when you need to go to the next one. And if you transfer that to energy production, electricity production, I mean, wind is old, and if you choose a performance criteria, like for example, energy density. I mean, wind going from wind to combustion is a big step in density. You go per molecule. But if you then take the step from combustion to nuclear, density, I mean, the factor in between is millions. You would need to do this logarithmically in order to really put it on a slide. And nuclear is actually not far on the S curve. I think it's already caught up with the existing technologies. That's why we have many countries still have fossil and nuclear and also renewables. But nuclear can do so much more and can develop so much more. And we'll see this with generation 4, because when it comes to density, we're still just using 4% of natural uranium, even after enrichment. You make the other uranium available via plutonium. I mean, this is you can actually multiply the energy density just because of this technical advancement by the factor 20. Put thorium in the game. I mean, there's another factor to multiply how much energy there is available. So I think we're just on the lower end of the S curve, and there's so much more to develop. But you need to participate, and this is why I think Germany should go back to nuclear and will go back to nuclear. But we're missing a lot before we do that, unfortunately. So that is actually the end of my presentation. I hope you enjoyed it. I hope it was food for thought. I hope it was technical enough for some of you experts, but still not too technical for those people that are not so familiar with the details and the backgrounds. So yeah. But yeah, feel free to give me comments, questions and answers, and we'll do this right now. We have, I think, 10 more minutes.
Yeah, thank you very much,
But I can
Martin.
even go longer.
Yeah, if you have some extra time, I think that we have enough questions for half an hour actually. But let's see if compacting them a bit, and I will do my best. Sorry for the people that have put the questions there. Some of them are repeated, so I won't say the names. I will try to condense them to pass them to you, Martin.
Yep.
And yeah, I will start from one of the first messages of your presentation, because you are concluding saying that Germany will go back to nuclear, and that there is a fast track and a slow track. From the beginning, this message was clear. And I think that people here are quite interested about the fast track. I even this morning when announcing the talk in LinkedIn, I put there a kind of a provocative statement saying that the restart of nuclear power plants in Germany could be the most transformative energy decision of Europe, because actually the new builds that the most pro-nuclear countries are proposing, the power plants will start operating in the second half of the 2030s.
Yep.
And is the German fast track competitive with this 10 years perspective?
Yeah.
Could it, in the, let's say, in the plants that are more intact, could this be faster? And yeah, maybe I let you comment on that. And
yeah, of course. I mean, it's difficult to specifically answer this question and give specific, I mean, values in what's the investment, what's the duration, etc. But we've had considerations, we've done estimates, and I think it's there's only a debate about how many plants we could start up again. In my opinion, personally, I think there's at least 3 plants which are almost no-brainer to rstart them, and then there's discussions. Is it 2 more? Is it 3 more? Is it 5 more? So I think the discussions range from 3 to 8 what could be restarted, and that's huge. And the timeline, we've been discussing this in KernD, and we shied away from giving a clear schedule, also because we were actually we asked politics or the utilities or anyone or the TÜV to actually investigate that, because I mean we're technical guys. We're not shooting numbers from the hip, which is good. it needs to be investigated. But we think that we can bring 3 to 6 plants can be brought back online probably before 2030 or by 2030. But of course, this is you need to have one long lead item that just that's on a critical path that messes up your schedule. You can have all kinds of difficulties with I mean, technical problems or just mistakes being done. I mean, nuclear is so safe. You're not implementing into the plant that's not been monitored really step by step, or manufacturing has been tested, and things can go wrong. And there is test steps in between before you implement it, because you don't want to have a technical risk, but you have a commercial risk, and even more so a schedule risk. I think the schedule is actually what decides about whether it's economic or not, and that is because once you decide to go back to nuclear, and once you want to have the fast track, you have to price in that you're going to have cheap electricity as soon as possible. And the more this end date drifts out, the more money you lose. So it's actually, I think, in the end, if you would do that as a utility, you would prioritize the schedule over the budget or the investment. But from our experiences doing replacements of these components, you can easily be per component, you can easily be in the range of 100 million, something like that order of magnitude. But then it also depends on the price of electricity. But the last plants in Germany that were, before they were then finally shut down, the last 3 convoy plants were extended by 3.5 months. And we know that the revenue doesn't mean profit that you can reinvest or they can use in order to pay out your investment, but the sheer revenue was rather getting close to 1 billion, eine Milliarde. And so we think bringing these plants back online would be in the range of few billions. Sounds big, but actually it's not big, not for nuclear, not if you go for 40 years or even 60 years. Yeah. And another example I want to give is, if you could, I mean, I'm a Star Trek fan. If you can take Emsland, which is a convoy plant, and you can beam it to Poland, and you can tell them, hey, what do you want to do with it? Want to have it? You can have it for one symbolic euro, but you need to start it up. Do you want to have it? And I'm pretty sure they would not hesitate to say this. Yes, please give it to us. Absolutely, because we're investing rather in the tens of billions for new plants with all the schedule risk, because you're going from greenfield to production with all the concrete and everything in there, having this big construction site, which is always difficult. Just replacing a few components is just like the later phase of a new build, and they're going through the whole new build, and they've not even started it. I mean, they would go for it. Yeah. And Germany, I think, should go for it too. But yeah, difficult. But I think that's the numbers we're talking about. I think it's several years, it's several billions, it's maybe 5 plants. But that's I mean, don't take this as granted. It's guessing, and I'm saying we need to take a look at it. Yeah, and then we'll know the number, and I think it will be surprising, positively surprising. Okay.
Yeah. So for this selling for €1, maybe we need to hide away the bureaucracy part. If we talk about bureaucracy, maybe they will not be so happy. But leaving this for
we would not give them the German democracy along with the plant.
Yeah. Okay. That's the ideal scenario. But continuing this here before, so just for, let's say, wrapping up the answer, we are speaking about a potential restart from almost 5 gigawatts to almost 9 gigawatts. You said before 2030, but even if it's in the 2030, this will be a pretty unique case in Europe. No country could put on the network as much nuclear in a shorter time. So this is pretty unique. And now your answer evolved little by little to the cost and to the price of this decision. So yeah, you spoke about also really positively that there is no component that we cannot replace in a nuclear power plant. But this is speaking about the replacement of a single company, of a single component, to kind of speak about a non-returning point from the technical point of view. Yeah. But actually, the returning point, it's a balance, it's a techno-economic decision, as you have said. Yeah. And I don't know, maybe you can give us, like, even if it's not a real case, just a kind of academic case. For example, is it techno-economic to restart a plant where you have already cut all the primary system and you only have the containment there? So in which point we could say, maybe this decision, this non-returning techno-economic point could be there for a plant?
So I mean, I think there's a gray area in between. I would say looking at the big components that naturally have a long lead time is the steam generator, because it's big steel and a lot of complex let's say interior, and it's all it's all comprehensive, it's all together. You cannot just replace. Once you start to cut the the small pipes in there, I think then the thing is gone. Then you need a new one, which takes time. And I think it's the same with the pressure vessel, plus the risk of not having that done before. But I think anything beyond that, when it comes to steel, I think is not a point of no return. So vessel head can be done. Reactor internals, in my opinion, is tricky, but is not a technical challenge, because it's not pressure retaining. So it's thin wall thickness. It's just very complex, but it usually even consists out of pieces. And when you cut internals, you don't cut all the way through all the pieces, but you take it apart, and then you start cutting one by one. So if you start with, you do the upper reactor internals, you do it before the lower reactor internals. So you may still have them left. And there's pieces that you can unscrew, so you can screw it back, for example. So I think internals, piping, vessel head, pumps is certainly not a point of no return. Beyond that, it becomes more difficult. But as we said, and I see that also now, I look at the chat, steam generators has been done before. Did even go wrong, and you could still start up the plant.
Yeah. So this being the worst case scenario is clear for also what you said, like speaking about tens of billions for restarting gigawatts of power. If we would make some fast numbers about the electricity price that we could provide to the market with the restarts, that will be pretty competitive. Mostly if you compare it with a new nuclear build, it will be much cheaper than that. But concluding on that point, I think that one of the most repeated questions after how many of them were there, how fast it could be, and how much it would cost, were around regulations. So maybe, because there were questions about how the federal and the state governments could interact, which will be the main challenges from the regulator, so from the German regulator point of view to restart. If there are any law that need to be changed to restart nuclear power plants in Germany. You mentioned that the Energiewende came with a legal framework that also complicated this a bit. So could you make us a kind of a description, maybe a step-by-step description of how this thing would look like if maybe tomorrow all the political parties in Germany agreed, okay, let's restart nuclear from tomorrow, let's start. How this process would look like from the regulatory and law and nuclear law perspective.
Yeah, I think that's a misunderstanding with a lot of people in Germany. It was, including myself, until I actually read into it, that there's the law that with an end date is forbidding the commercial or the production of electricity using nuclear fission on a commercial basis. And that's what is not allowed in Germany anymore. And after the end date, which was given plant by plant in the law. But that means, and it's Uwe Stoll, who may be known to some of you, or you said as a joke, you said like if the utilities would have said, you know, we do something really funny. We produce electricity and we give it away for free. It would have been allowed. And so that, but still, I mean, of course, you want to do it commercially. That law would need to be changed. And I talked to some lawyers and I said it doesn't even require a 2/3 majority. It could be done with a single majority. And funny enough, there is, if you take certain parties who actually don't work with one another, and I'm not giving any names because I don't want to be political, because this is about technology and economy, but you take together a few parties, you would actually have a majority for restart, which is interesting. I mean, but I want to put the parties and whatever they do aside. But that means that you have a majority in the public who actually voted parties that would favor nuclear. It's interesting. Well, cannot make that decision, although it would just be a single majority. But I think the biggest problem by far is that any investor that would come into Germany, and they might come from the outside, and it's easy to imagine that Google and these hyperscaler type of guys would be interested to build data centers and rely on nuclear, because there's nothing else you can actually do in order to run data centers with stable electricity, CO2 free. Is actually, you cannot do this with wind unless you have a lot of water power. You got to go nuclear. And so these investors could come to Germany, but you need at least 20 years, I think, in order to operate, and not have the next government and the next government to turn it upside down again. And unfortunately, that's what I meant with when you're on the other side of that hill and you're on the non-nuclear side, you have a precedent what can happen. And that scares people and investors and utilities and politicians a lot, in order to go back on the other side, because they know we've gone there once, we can do this potentially again. And you need to, I mean, in order to have also fuel delivery contracts, you need 10 years at least. 20 years would make sense. I mean, this investment, as I said, I think it pays off quickly, but it's not about just getting your invest back. I mean, you want to do a margin and profit with those plants, of course, in the long run. And therefore you give something to the public, of course, which is extremely valuable beyond the price. And you can still have lower electricity prices, investors getting their return back, utilities having profit. But I think you also need, and for that reason, I think the German utilities say, well, we're not doing nuclear anymore, which would then mean you actually need a new utility structure, and maybe have one nuclear utility instead of these different utilities, who now of course focus on other forms of energy. So you could do that, and you could have it partially state owned, which would be just the minimum guarantee that that the state and thereby politics is investing into this long-term plan. So you make them part of the investment. But yeah, all of that, I mean, you need to build something that gives certainty for your investment. Yeah. 20 plus years, ideally 40 years. And that's the big problem we have. And that's, I don't know, something probably needs to happen, but there are things that can happen. So Germany would go back, as I said, but yeah, maybe it's we're not quick enough to keep everything alive with restarting the existing plants, because that would secure, I mean, everything.
Yeah, indeed, it has just been mentioned in the chat. There are a lot of ongoing discussions currently in Sweden to know how to protect final investment decisions
Yeah.
from a change of government in their new build plan. Let's see what they do, and if the others can learn from them to kind of decouple the policy changes from the long-term investment needed for nuclear. But before I really want to address two more questions before finishing, Martin, at least. So one of them is about human resources, because one of the questions was, okay, Framatome and Westinghouse may have the technical knowledge to start or to launch a restart nuclear to restart the nuclear power plants in Germany, but how did, or maybe have the companies kept the needed human resources to do it? There was there a kind of a talent retention program to make this happen in case it could happen, because at the end, currently in Europe, the countries are fighting for these human resources. So how do you see this in Germany at the moment?
Yeah. I mean, one thing is, and that's a message to Germany, is that, I mean, with the nuclear renaissance that's happening, in my opinion, all across the globe, and especially now in the US, which is of course is Westinghouse home market. I said the nuclear world, the nuclear industry is not waiting for Germany, and even Westinghouse in Germany, and also Framatome, the other companies, KSB, and all of them, we all have good international business, and it's not that we live and die with the German nuclear power plants being operational or not. But that's the good side to that, is that we pretty much kept our let's say our HR or our resources, because nuclear has turned so much global, and that's an advantage. So that means there's still let's say at least a base load at least when it comes to the suppliers and the manufacturers and the service companies. There is still a base load of resources in Germany, and they're usually, and it's the same for all the other companies, they're well connected to the let's say the other entities of Westinghouse, for example, in that case. So we can bring international teams, and they can be led by maybe a German like shift lead or project lead, and we could integrate people from Sweden, from France, from Spain, etc. So that's working, and we're actually practicing that all around the world. When it comes to operators, more difficult. I know from talking to people that when I think 2 years ago, it was discussed whether or not we could keep the last three plants running, and it was decided not to do so. I know that some of the operator type of people were pretty excited, and I think we would have still got a lot of people even kind of coming back from early retirement and all of these deals that I had, saying like, hey, if Germany wants to go back to nuclear, we want to help. You would need to try and do this again, and I don't know, and that needs to be evaluated, how much you would get and how long it would take to actually educate I mean the personnel for the plants itself. There's still a lot of people on site, but I think the problem is really the operators and having licensed operators. And I recall that when Baraka in the UAE finally came online, actually they were delayed according to the initial plan, rather because they were not quick enough with educating the personnel and not with finishing actually the plants and the buildings. So it will be a problem. But I think is the longer we wait, and the longer we wait to look at that and also send a signal to those people interested, the more difficult we'll get. And I think that's kind of the downward spiral in which we're just circling down here in Germany. And yeah, time is running out.
Yeah, pretty interesting. I'm tempted to play a bit the devil's advocate here, because I fully agree that in terms of nuclear engineers, there won't be a problem because you have a lot of international support. But as you said, the operators or maybe just the people that need to do the welding and the small repairs in the. So welding is also a very high technical topic, but the no so highly technical. So the mechanical engineers, electrical engineers that need to be at the plant working there. I do suppose that this would be a challenge for Germany at the current moment, right?
Yeah, I cannot contradict. Yeah, but as I said, I mean, I turned it positive, saying like, I mean, give it a try. I mean, see how big the problem really is, and then deal with it. Yeah.
Absolutely. And the last one, some of them won't be fully answered, but I think that we cover most of the high level topics. But the last one was also related to what you said. So let's do a report. Let's do a serious study about this. Let's put experts together to evaluate how feasible is this in all these terms: economic, human resources, technical, and so on. And a lot of people is asking on the chat if there is any report that have already evaluated this so far. The Radiant report was mentioned there. I don't know if you will be in a position to endorse it or recommend it or not. But also there was the serious question of a recommendation, any literature recommendation for the people that have attended today the session. If there is something that they can read to extend a bit the knowledge that you have shared today.
Yeah, I mean, I think is there is no profound study out there, as much as I know. I appreciate the Radiant study a lot, but for me, the Radiant study it's already outdated. I think it was very high level, and it was more of a wake up call. What's feasible, but not so much I don't know, something like a handbook for investors to say, okay, this is going to be the schedule, this is going to be the investment. Not even that's going to be the number of plants, because even that can be debated. So I think that study should happen. We've not done it because for us as an industry, for example, it's also difficult to do this study. I think the TÜV, for example, like the technical expert organization, would be perfect to do a study like that. Ideally, you do a study while stopping dismantling. Of course, otherwise you're targeting. You have a moving target, but even that would not be so difficult because I mean these segmentation projects they run for a long time. I mean you segment a component. And some of them, like the intros, takes a year or two. So you can do a study unless it takes 5 years. I mean, if the study itself takes 5 years, then it's you do something wrong with the study. But I think the problem is really in the German environment. You need to do this with credibility, because you got to do it once and then you got to use that study, and don't come with no, we want to have a counter study and another counter study. So I think giving it to the TÜV or some organization that's reasonably neutral but at the same time knowledgeable would be the right thing to do. And it of course, a moratorium to the dismantling, stopping the dismantling would make a lot of sense because it's really logical, but even that is not absolutely necessary. I wish somebody would do this study, but I can tell you at least what I think for now. If the industry, like Westinghouse doing this, it would not. You need to reach the public and you need to reach the politics with that, and it's not so much. Reaching. It would be worth it, giving it also to the investors. And I think there would be investors coming from outside of Germany coming in, so they need to be educated in what it really takes. But they will still hit a wall if politics and public opinion doesn't change. So that's where you need to address it to, and that's why it needs to be neutral. And you probably have, I think, one shot.
Thank you very much for the reflection, Martin. We are now running actually out of time. So I may just give you the opportunity to close. You have passed us a lot of positive messages. That is something really that I really appreciate, because sometimes in nuclear we really focus on the problems and challenges, and we forget the positive things behind the positive things that we can do if those challenges are properly or successfully addressed. So this is something that comes from a podcast that I listen so frequently, and to the people giving the speech, they give a magic wand. So you can choose a single thing that you could change in Germany, in the world, in wherever that may get you closer to the objective of restart nuclear power plants in Germany. So I'm giving you this magic wand as for the closing statement. For you can think I can extend a bit the question. This is a pretty funny thing. So please just share with us which magic thing you will do for creating the conditions of that can make the restart of nuclear power plants in Germany closer.
So what is the magic word? What is the essence of my presentation? There's several candidates to have one. I mean, to put it all in one word. I think one candidate would be feasibility. I think we need to take a look at the feasibility in detail. I mean, Germany, to make sure we understand how can we restart the plants, what would it cost, and what would be the timeline. If we don't do this analysis, we're actually flying blind, and we may waste a really, really good opportunity to change our situation to the better. So feasibility is one candidate, but I think probably my favorite would be future. Future, because in my opinion, being nuclear, going back to nuclear is going to be absolutely essential for the future of our existing industry, but also for the future industry in Germany. I mean, you cannot do AI, and you cannot do data centers with renewable energy. As sad as it is, you need stable electricity, you need baseload type of electricity, and it's got to be CO2 free. And that's why you need nuclear if you want to use data centers and work with those hyperscalers, have them come to Germany, have them invest in data centers in Germany. I mean, the future is nuclear. I think
Thank you very much. Thank you very much, Martin. So this is it for today. Thank you.
Thank you.
Thank
you for listening so long. Thank you for listening even longer than was originally scheduled. Hope you got something from it, and
see you soon.